Continuing with right triangles, let's talk about some of our special right triangles. And in doing so, we're going to look into the 45-45-90 right triangle and then the 30-60-90 right triangle. Now, they have some special characteristics that are all derived from the Pythagorean theorem, or we can prove them using the Pythagorean theorem. And but by accepting some of these common ratios that occur and that the triangles are all similar, it will definitely, or should I say, all the 45-45-90 are similar, and all the 30-60-90 are similar. So by understanding these ratios, so if I take and what we have here in the beginning is it talks about the 45-45-90, and it says that we basically, when a diagonal of a square forms two congruent triangles, and they're isosceles triangles because my legs would be the same length, and the other angles, so if we have a right triangle, my legs are the same length, we have the base angles are going to be 90 divided by 2, which is going to be 45. So we end up with a 45-45-90 triangle. Now, if we were to try to find what the length of the hypotenuse, we could do that using the Pythagorean theorem. And in doing so, this would, A, B, C, and we know Pythagoras said that if you have a right triangle, A squared plus B squared is equal to C squared. And if we were to do the, just go the formula, we could just say, hey, my side length is going to be, and I'm just going to put a 5 in there. Well, if that's the case, we know that B is also 5 because a square has the same length sides. So I would have 5 squared plus 5 squared is equal to C squared. So I have 25 plus 25 is equal to C squared. So I have the square root of 50 is equal to, we have 50, right, is equal to C squared. So C is equal to the square root, and let's see, make sure we know I do the square root of both sides. So the square root of C squared is C is equal to the square root of 50, which is going to be equal to the square root of 2 times 25, or when I simplify that, that would be 5 square root of 2. So what we'll find out here in this case, C is equal to 5 square root of 2 when we simplify the radical. Well, this theorem, 45-45-90 theorem, states that if we have a 45-45-90 triangle, the legs are congruent, yes, it's isosceles, and the length of the hypotenuse length of the hypotenuse h is square root of 2 times the length of the leg. And that's what we have here. We have the square root of 2 times 5, which is the length of the leg. So whatever the length of the leg is, we can multiply it by the square root of 2, and we find out what our hypotenuse is. So here in this little drawing over here, if I said, hey, my leg length is 7, then this would be 7, and then the hypotenuse would be x times the square root of 2, or the length of the side times the square root of 2, which is 7 square root of 2. So just knowing that allows us to find a lot of the information. So looking at example number 1, it says find the hypotenuse length given the angle measure. Well, given the angle measure, if we know that this angle measure is 45, then we know that this angle measure is 45. So then we know that we have an isosceles triangle, or the 45-45-90, and so this would be 4, and of course this would be 4 and the square root of times the square root of 2. So that is how we could come up with the length of the hypotenuse, in case we needed to fill any of that stuff in. And then we also know here that as I start to look at this check becomes a little bit different now because they gave us a radical. They gave us a radical for the side length. But either way, we know that the hypotenuse is equal to the side times the square root of 2. So in this case, I just say, hey, well, the hypotenuse is equal to the length of the side, which is 7 square root of 2 times the square root of 2, which happens to be x is equal to 7 square roots of 4. So x is equal to, we know the square root of 4 is 2, so 7 times 2 is 14. So in this case, x is going to be equal to 14. We had to do some, movement and combining of the radicals and so forth and so on. So just going through the motions and solving with the information we have. Look at this next example. Now as I come over here, let's see here, finding the hypotenuse length given the side measurement. Okay, well, let's see again. If this side is congruent to this side, that means that we do have that 45, 45, 90 triangle. So I know then that the hypotenuse is again equal to the side length times the square root of 2. So the side length is equal to 5 square roots of 2 times the square root of 2, which is, again, x is 5 square root of 4, which is going to be 5 times 2, which is 10. So 5 times 2 or 10. So Jen, just being able to use that ratio definitely makes things easier. That's much easier than doing the Pythagorean theorem every single time. So let's see. This is my side. And I know that my hypotenuse is going to be equal to the side length times the square root of 2. So it should just simply be 8 square root of 2. 8 square root of 2. All right, so as we move on, 45, 45, 90. Ooh, gets a little bit more difficult here because we do have to start to rationalize the denominator. Okay, so we know in this case, thinking about what's going on, find the value of x. I know that the hypotenuse is equal to the side times the square root of 2. All right, looking at this equation, I can say, hey, I know the side length is x, and I'm assuming I got 45, 45, 90, right? Because I have that 45-degree angle, so my side lengths are going to be the same. So in this equation, if I know that they've done it a little bit differently over here, but I'm just going to substitute in for my side length. My side length is x. So x times the square root of 2 is equal to 18. Divide both sides by the square root of 2. And then x is going to be equal to 18 over the square root of 2. You can't have that radical in the denominator. So we have to rationalize that denominator. And we would do that by simply multiplying it times itself. Square root of 2 times the square root of 2 is going to give me that whole number I'm looking for. But I can't just do that. I have to multiply it by the square root of 2 over the square root of 2, because that would then be multiplying something by 1, and I can multiply anything by the value of 1 and not change it, just change what it looks like. So this would be x is equal to 18 square root of 2 over the square root of 4, which is 18 square root of 2 over 2, and then 18 divided by 2 is actually 9 square root of 2. So it turns out that my side length is going to be 9 square root of 2. Now, there are different ways to do that. There are possibly shorter ways to do that. It's actually really easy, but if we lack that skill of being able to rationalize the denominator with radicals, then it becomes the challenge. That was the hard part here. It shouldn't take a lot of effort to that, but again, if we're lacking that movement, and if I go back here to theirs, they said that the hypotenuse is equal to the length times the square root of 2. So 18 is equal to x times the square root of 2. They divided both sides by 2, which is what I did, square root of 2. And then they had to rationalize the denominator. So getting from here to here is all rationalizing the denominator. And let's see here, looking at this, again, I know that my hypotenuse should be equal to the side length times the square root of 2. If I divide both sides by the square root of 2, x is equal to 5. And of course, square root of 2 divided by square root of 2 is 1. Square root of 2 divided by the square root of 2 is 1. That's how x is simply equal to 5. Again, some people might say, I don't need to do an equation to do that. I can see the answer, but it helps clarify in case that, we can do the easy ones, then we can do the hard ones. So looking over here to the next one, we have the 30, 60, 90 triangle, and it is derived from a equilateral triangle, equilateral, equiangular triangle. And I will just say that we turn out that you can prove it all based on the based on the Pythagorean theorem. But what we have is, it turns out that my side lengths would be, let's see here, 1, 2, square root of 3. Those would be my side lengths. So in the Pythagorean theorem, if I were to work that out. So the ratios, 1, 2, square root of 3. So the short side is 1. The long side is going to be the square root of 3. And then the hypotenuse is going to be 2 times the short side. So 1, 2, square root of 3. Now, if I were to do the Pythagorean theorem, and I were to call that A, this would be B, this would be C, I would have A squared plus B squared is equal to C squared. That would be the square root of 3 squared plus 1 squared is equal to 2 squared. So this would be 3 plus 1 equals 4, and sure enough, 4 does equal 4. So that is a Pythagorean theorem, and it proves that those ratios work. So the ratios turn out to be, and they put it here, that 1 square root of 3, 2. So we just pick a side length, whatever that side length ratio might be is, and all of these triangles will be similar. So if I think of it this way, that x, 2x, and x square root of 3. And I like to think this is the long leg, this is the short leg, and this is the hypotenuse. And I can pretty much manipulate this information now. Looking at this, and they've come up with some information, but I do know that, goodness, they dropped that radical right there. I know that this is equal to the short leg, which, the short leg times square root of 3. That is equal to the short leg, which happens to be x, times the square root of 3, is equal to 12. And then the x times the square root of 3 is equal to 12. Of course, rationalizing and simplifying that denominator, we end up with x is equal to 12 over the square root of 3, multiply by the square root of 3 over the square root of 3, and I get the square root of 9 over 12 square root of 3. And simplifying that again, that would be 3 over 12 square root of 3. That simplifies to 4 square roots of 3. 12 divided by 3 is 4. So that's how they rationalize that denominator. So going from there to there is a simple process, but if we don't know what we're doing, we have to take step by step. Now, if I'm able to find out that the value of x is 4 square root of 3, then, well, in order to figure out what in the heck y is, this is going to be 2 times x. So I could say that y is 2 times 4 square root of 3, or in this case, 8 square root of 3. And then that would allow me to solve that information. So understanding what do the ratios mean? What are the ratios? So take a minute, look at this next problem, and then from there we'll go ahead and check your answers. So looking at that, I'm able to come up with, again, this side is x times the square root of 3. This side is simply x because that's my short side, and this side is my hypotenuse, which is going to be 2 times x. So when I calculate x square root of 3 is equal to 15, I go over here, I divide both sides by the square root of 3, I get 15 divided by the square root of 3. To rationalize the denominator, I multiply both the numerator and the denominator by the square root of 3, so I get 15 square roots of 3 over square root of 9. Square root of 9 is actually 3. So 15 square root of 3 over 3 is going to be 5 over the square root of 3, because 15 divided by 3 is 5. So that turns out to be x. X is going to be 5 square roots of 3. Well, if my y value over here is simply 2x, my hypotenuse, 2 times x, I just say 2 times 5 square roots of 3 would be 10 square roots of 3. 10 square roots of 3. And that's utilizing the information I have, using the theorems that they've given me that are much quicker by understanding those ratios and those values than doing the Pythagorean theorem. You could, but we don't want to. Okay? given enough information, of course, we couldn't have used the Pythagorean theorem here because it only gave me one side. So moving on here, this is a crazy problem right here, but I will just say that Destiny makes and sells upcycled earrings. The earrings shown are made from congruent equilateral triangles. Equilateral triangles, bam. This is equilateral triangle that makes this 30, 60, 90. Each triangle has a height of 2 centimeters. This would be my height, 2 centimeters. The hooks attached to the top of the earring and are 1 centimeter tall. Okay, so that's 1 centimeter apparently. Destiny needs to mail this pair of earrings to a customer. If she mails the earrings in a rectangular box, what width and length must the base of the box have so the earrings will fit if they are placed side by side in the box, bottom of the box? If she mails the earrings, okay, let's see. If the height there is 2, and I'm just thinking about it, if that was my triangle, here's my 30, 60, 90. It's not very pretty. 30, 60, 90. And this is 2, which I know is going to be x square roots of 3. This is going to be x, and this is going to be 2x. And I don't necessarily need to find this value, but I do need to find this value because I would have to find out how far, how wide of a space does it take up for me to lay these earrings flat on a box? So the task is to find the width and the length of the box, and we're going to need to calculate the height and the width of the earrings. And doing so, I just calculating in at some point in time, if we know the height of the triangle or the earrings, then we should be able to use that to come out with what is this portion of the width and then double it. Or we should probably be able to tell that is what information. So let me see here, solving this, I know that x square root of 3 is equal to 2, divide both sides by the square root of 3. So I have one piece, this right here is going to be 2 square roots of 3. So if I have 2 square roots of 3 and then this is 2 square roots of 3, the width is going to be a total of 4 square roots of 3, right? 4 square roots of 3. I think they give us that down here. The width of the box must be at least 4 square roots of 3. And then, of course, if you do the rationalize in the denominator, you would end up with 3 over 4 square root of 3. So that would be my other possible answer. Let's see, what else do we know? We know that the altitude of the triangle measures approximately 2 centimeters because they told us that. That was part of the given information. And the length of the box for one earring, sorry, this goes up here, right? I put it in the wrong spot. The length of the box for one earring is 4 square root of 3, sorry, and then 4 square root of 3 over 3. I put it in the wrong location. Me not reading well. The width of the box must be at least, well, if we're going to put 2 earrings next to each other, right, we're going to have to multiply that times 2. If one earring is this wide, then the second earring would be times 2. So I think we would end up with 8 square root of 3, or in decimal form, it's probably 4.62-ish. So there you go. So the width must be 4.62 centimeters, and then the length of the box must be at least how many centimeters. And then I guess what we have to remember here is talking about the length of the box, looking back at it. They said that this hook was 1 centimeter. They said the altitude was 2 centimeters. So this altitude would be 2 centimeters. So the length of the box needs to be then at least 1 2, 3, 4, 5 centimeters. Because it's not, this is two different earrings here, you know. It's just a very long, dangly earring. So that's 2, coming up with that information. So there's working through using those special right triangles, and of course the ever challenging rationalizing my denominator. So that is basically our special right triangles, and again, can all be derived using the Pythagorean theorem. This would be 2x, this would be x, this would be x square root of 3, and then a 45, 90, not a very pretty triangle, but 45 degrees. We would know that this is congruent to this, and this would be x, this would be x, this would be x square root of 2, and using those ratios.